Here's a quick little lesson on matrices. See, a matrix or matrices is a handy way to organize and hold lots of data. They're really, really popular now with huge data sets. It's a good way to organize data. It's basically just a spreadsheet. They're very powerful. They have tons of applications and uses. However, they have their own special rules and ways we use them in math. The beauty of matrices is they're very computer friendly. Some quick applications. One is large systems of equations. Previously, we solved systems of equations either by elimination, substitution, or graphing. There's a fourth way, it's called Cramer's rule. Or Cramer's method. And this will let us solve systems of equations for as many unknowns as we want. So we've pretty much just done 2 equations, 2 unknowns, or maybe 3 equations, 3 unknowns, which are kind of cumbersome. But this will get up to n equations with n unknowns, especially with computers. The second thing off the top of my head that I remember about the application of matrices are translations. Remember, in the past, if we had an object and we wanted to rotate it to know the new coordinates, in the past we only did 90 degrees, either plus minus 90 or plus minus 180. With matrices, we can do that at any angle. That's something we will get to a little later. But for now, we're going to start with just some of the vocabulary and some examples of how we're going to use matrices and develop some of those skills. So let's say you have cars and trucks. Car and truck, and you're the manufacturer, and you want to know how many cars and trucks and how many parts you need to keep on hand. So if somebody gives you an order, how many bumpers do you need? How many wheels do you need? And the number of wheels or bumpers or gas tanks for a car may be different than a truck, which may be different than a motorcycle. Matrices can help us solve some of these sort of things. So let's start with the cars. Let's say a car has 4 wheels, 2 seats, and 1 gas tank. So wheels, seats, gas tank, or tank. Okay? And let's say the truck, kind of like maybe a pickup truck with dualies, has 6 wheels, 1 seat, and we're gonna go big. We're gonna call it 3 gas tanks. Okay? What I have created is just a little chart up here, table. We're gonna give this make this into a matrix. So we put these brackets around it. Okay? And the notation here is we're going to call this matrix A. It's an uppercase letter A. Okay? Couple notation things. Going side to side, this is going to be rows. Okay? And going up and down will be columns. Okay? And we will use the rows and columns to talk about its dimensions. So this one up here So the dimension is going to be rows by columns. So this one here is 1 row, 2 row. So 2, 1, 2, 3, 2 by 3, or it's simply a 2 by 3 matrix. Along with this dimension, every spot has its own address, I guess you could say. So if I want to look at this spot right here, this is going to be matrix A. So we already talked about the A, so we know A is a 2 by 3. And this is going to be 2 by 2, A2, comma, 2. A22 is that spot. And these are just little handy things we got to just kind of keep in our back pocket, some tools we're going to need to pull out as we go through this. Okay, so let's go see how we use these a little bit. I'm going to stick with this matrix as an example quite a few times. So what does this look like? 4, 2, 1, 6, 1, 3. Okay, here's A again, and I'm just going to add them. When you add matrices, you add each individual piece. 4 plus 4, 2 plus 1. It's just going to be like that, okay? And I have my result will be another matrix of the same dimensions. So 8, 4, 2, 12, 2, 6. Kind of ran out of space. 12, 2, 6. Okay. No problem. Okay, how about this one? What if I did this? 4, 2, 1, 6, 1, 3. Again, that's A. That's just our A matrix. And I'm going to multiply it by a scalar. How about the number 3? Okay, so I can multiply this by a scalar and get an answer over here. It's just going to be multiplied through everything. 12, 6, 3, 18, 3, 9. So multiplication will just be like subtraction also. You add and subtract the corresponding components. Multiplication by a scalar, everything gets multiplied by that value. Division by a scalar will be the same, subtraction will be the same,